Welcome back. It's holiday time here in Auckland at AUT, and so just to keep myself busy, I thought I'd have a look at this H-bridge which I got from AliExpress a while back. The beautiful thing about it is it's 100 amps per channel MOSFET bridge. Ali even gets heated up when I use it to drive this little cart that I'll show you in a minute. It's powered by just a PC power supply, and it's controlled from a myRio, and it's just basic logic that's going into it, nothing special. And over here is the cart that was made up. You see at the back of it there are two caster wheels, they're quite big actually, and at the front there's two motors which are wheelchair motors of the Century which we had before, and those run off 12 or 24 volts. I'm running them off 12 volts. This thing is made up from aluminium in the workshop, and it's quite robust, as you'll see with the demo. I'm controlling it by the steering, by differential steering. That's to say, slowing one or speeding up one wheel relative to the other, and then it'll turn. Not doing a lot of that at the moment, just doing basic turns. Haven't got any fancy algorithms for doing sophisticated steering, but controlling it here from Microsoft joystick, which is connected to the myRio. And I've got an umbilical cord, which I've got to be careful, of course, I don't get that tied up in the wheels, which has happened, of course. So that's just for the power supply and the control signals. Of course, it could be all put on the cart, but it means having a battery and recharging the battery, so I didn't bother doing that. So I've just put a temporary umbilical cord onto there because I'm not going very far. And let's see how this thing works. So first of all, we'll have a look at the program. So the program, there's the front panel. It's kind of a bit rough and ready. So the steering for this thing, because it's got no movable wheels, of course has to be done like a differential mode, differential steering it's called in the robotic circles, or tank steering. So you have to move one wheel slower than the other and it'll turn. So I'm kind of doing that. I'm not really doing a lot with this at the moment. I'm just sort of going forward and back and doing some turns just to test out the H-bridge. There's the program. It's just a real-time loop, 2 PWMs, one for each motor, running at 10 kilohertz. The reason it's running at 10 kilohertz is so you don't hear it, basically. There's no great reason other than that. You can run it at 1 kilohertz, but it makes a whining noise coming from the motors. So 10 kilohertz or higher. And the rest is just very basic logic, turning one motor on and one motor off and so on, and sending data out the digital ports and in the digital ports and so on to control the H-bridge. So it's pretty straightforward. And so we are going to do a quick demo. I'll just do it by the mouse first, just compile it. So I click this thing that says mouse control, it goes on to that, so I should be able to press the button. Oh, there's it going backward. How do I, oh, that should go forward now. And we can rotate it and so on. I'm not going to rotate it at the moment. Instead, I'm actually going to sit on it and see what happens. That should be quite interesting. So, don't do this at home, whatever you do. I've got a chair on top of it, and I'm not going very fast. I'm only going at half speed. So, I'll sit on the chair and we'll control it from here. Forward, there we go. Back, And that way, round to the left, forward, reverse, oops, that way, there we go. Let's go down here, oops. I'm going to watch and not pull the cable, of course. And that's it. Very interesting.